Hello dear kids, welcome back to our geography class. Today we are going to revise few things that we have already learned in the previous class. It was all about some imaginary lines. Imaginary lines, what it can be? Yes, you are right. It's all about longitudes and latitudes. So before we move to the topic, I just want to remind you what is longitude and what is latitude. So for this, I am taking you to our park. Shall we go? Yes. And dear kids, we have reached in the playground area. Do you remember this place? Yes, really good. So this is what? The swing. Good. And here you can see, oh my god, it's not moving. I don't know. So this is what? Merry-go-round. And also we can see some more things. What is this? You remember? Yeah, this is the most favorite thing. That is swing. Really nostalgic feeling. Great. Okay. Fine. Good. And now you can see another one thing over here. Do you know what is this? Yeah, this is a slide. Here you can see a ladder in which we used to climb over it. Right. So in the ladder you can see some steps over here and a rod here to hold our hands. So dear kids, can you compare into our imaginary lines on a globe? Can you compare it? Yes, we'll try. So here you can see horizontal lines or horizontal steps. Horizontal lines on a globe is known as latitude or longitude. Correct, it is latitude. And here you can see a rod to support. Here we hold to support vertical lines. This is known as good longitudes. So we keep our feet on latitudes and hold on vertical lines, that is longitudes. And what we will do here, we will, wow, oh nice. Okay, shall we repeat it again? Good. So here the horizontal steps are known as latitudes. We keep our feet on latitudes and hold here for supporting, that is vertical lines, longitudes, and we'll enjoy here once again. Wow, very good. So dear kids, if you want to remember what is longitude and latitude, just remember this sweet slide. Okay, so here you can see the latitudes, that is horizontal lines, and here the long lines or the long vertical lines, that is longitudes. Is it okay? Good. So dear kids, now I hope you have got a clear idea about longitudes and latitudes. So now let's come into our topic. Here we discuss about a globe. Okay, so a globe is a small three-dimensional model of the earth. Right, so this is a globe. So it is mounted on its axis so that it can be rotated freely, just like earth. So it can be rotated. Okay, so it shows us the exact shape of the earth. It shows the exact shape of the earth. Spherical, slightly flattened at the poles and bulging at the equator. It is known as what? Yes, geoid. It's known as geoid. So the different physical features like oceans and continents are shown on the globe. Okay, physical features like this blue color, oceans and continents are shown on the globe. So it is too difficult to find or locate a place on a globe, is it? So it is too difficult for us to locate because a sphere does not have any side or corner. So we need to have certain points or lines which can be used as a reference for locating places on earth. Clear? So the imaginary line on which our earth rotates is called its axis. Okay. So the imaginary line on which our earth rotates is called axis. So it passes through the center of the earth and its ends, two ends are known as poles, North Pole and South Pole. So the pole towards the north is called the North Pole and the pole towards the south is called the South Pole. Clear? Good. So the next is the imaginary line drawn exactly midway between the two poles is called the equator. Here you can see a line over here. So this is the imaginary line. Okay, so the imaginary line drawn exactly midway between two poles, that is North Pole and South Pole, is called equator. It divides the earth into two equal halves or hemispheres. North part of the equator is known as northern hemisphere and the part to the south is called southern hemisphere. Northern hemisphere and southern hemisphere. So a set of imaginary horizontal lines drawn between the two poles and the parallel to the equator are called the parallels of latitudes. Okay, so here you can see the latitudes. Then this run east-west direction. East-west direction. Another set of imaginary lines drawn from the North Pole to the South Pole are called meridians of longitude. Just remember the facts which we learned already. Okay, so they run north-south direction. Got it? So now we are going to learn something more about latitudes. Okay, this you can see the model here. These are known as latitudes. Clear? So the latitude of a place. What do you mean by latitude? First we will learn what is latitude. Okay. So the latitude of a place is the angular distance. It is the angular distance of that place north or south. Okay, north or south of the equator measured from the center of the earth. Okay, so it is measured in degrees. The distance between two degrees of latitudes is almost 111 kilometers from one line to the next line. How much it is? 111 kilometers each. Okay, so each degree is divided into 60 minutes. 1 degree is divided into 60 minutes. Learn all these facts. Okay, as the equator is the starting point, it is considered to be 0 degree latitude. So equator is considered to be the 0 degree latitude. So the angular distance of the equator is 90 degree. Okay, so angular distance total from here to here it is 90 degree. So the North Pole is marked as 90 degree north latitude while the South Pole, while the South Pole is marked as 90 degrees south latitude. North Pole is marked as 90 degree north and South Pole is marked as 90 degree south latitude. So, the latitudes are drawn an interval of 1 degree. 1 degree is 1, 2, 3, 4 like that. One line is 1 degree. So, will thus give us 90 parallels in each hemisphere. So, here you will get 90, here also you will get 90. So, 90 plus 90, how much? Yes, 180 latitudes. For total, how many latitudes are there? 180 latitudes. 90 in the northern hemisphere, 90 in the southern hemisphere. Good. So, the equator is the longest latitude. The longest latitude is equator. Remember, equator is the longest latitude. See, as we move away from the equator towards poles, while we move away from the equator towards poles, what will happen? The length of the parallels will decrease or increase? Yes, the length will decrease. Clear? See, the north pole and the south pole are just 2 points. You can see, can you see here? Here. So, here 1 point and another 1 point is here. Good. So, all latitudes in the northern hemisphere are denoted by the letter N. So, whatever is coming here in the north hemisphere, it is denoted with the letter N. So, while the latitude in the southern hemisphere are denoted by the letter S. Yes. Here it is S, here it is N. So, now let me ask you, are you remembering the important parallels of latitude? In 5th grade we have learned. So, we will recap here. Listen. The equator is the most important parallel of latitude. Equator is the most important. Then, other than the equator, in each hemisphere, we consider certain parallels to be important as they help us to divide the earth into different zones. Okay, so let's see. They are called the Tropic of Cancer. Tropic of Cancer, what is the degree? 23.5 degree north. And Tropic of Capricorn, that is 23.5 degree south. Then the Arctic Circle in north, that is 66.5 degree north. And the Antarctic Circle, that is 66.5 degree south. So, these are the different parallel or important parallels of latitude. Is it clear? Good. So, now we will discuss about the heat zones. Okay. So, the earth can be divided into how many heat zones? 3 zones on the basis of the amount of heat received from the sun. So, these are what? First one is torrid zone, the next is temperate zone, and the last one is frigid zone. So, now let us discuss about torrid zone. Okay. So, this zone lies between Tropic of Cancer and Tropic of Capricorn, 23.5 degree north, that is Tropic of Cancer, 23.5 degrees south, that is Tropic of Capricorn, and is also known as the tropical zone. So, torrid zone is also known as the tropical zone. So, this is the hottest zone on the earth as it receives direct rays of the sun throughout the year. You can see. So, it receives direct sunrise throughout the year. Got it? So, we will move to the next, that is temperate zone. So, there are 2 temperate zones on the earth. There are 2 temperate zones on the earth. The north temperate zone and the south temperate zone. Got it? So, the north temperate zone lies between Tropic of Cancer and the Arctic Circle, 23.5 degree north, Tropic of Cancer, and 66.5 degree north, that is Arctic Circle. While the south temperate zone lies between the Tropic of Capricorn and the Antarctic Circle. Tropic of Capricorn is 23.5 degrees south and Antarctic Circle is in between 66.5 degree south. Got it? So, the temperate zones receives slanting rays of the sun. Okay, it receives the slanting rays of the sun. Here you can see, and thus are neither too hot nor too cold. It is neither too hot nor too cold. Okay, and the last one, that is frigid zone. Like temperate zone, there are two frigid zones. Clear? So, one in the north and another one is in the south. The north frigid zone lies between where Arctic Circle and the North Pole, and south frigid zone is between Antarctic Circle and South Pole. See, these two zones receive extremely slanting rays of the sun. Thus, these zones are very cold. Very good. So, these two zones are very cold. Got it? Good. So, our next topic is longitudes. So, if you just know the latitude of a place, it will indicate only its position north or south of the equator, right? So, this is not enough to locate a place on the map. Clear? So, as we know, the equator is the reference line for the north and south. We also need a reference line to locate places in the east or west directions. Clear? Since, look at here, these are latitudes. Since all meridians are equal in length, see, all the meridians are equal in length and run from North Pole to South Pole. Run from North Pole to South Pole. One particular meridian had to be chosen as the reference line. Okay, one should be there, like equator, one should be there as a reference line. So, it was decided by all the countries that the meridian passing through the British Royal Observatory at Greenwich near London. Okay, so all the countries select what? The meridian which is passing through the British Royal Observatory at Greenwich near London would be taken as the starting line. Okay. So, it is regarded as the 0 degree longitude and called the prime meridian. So, you can see this red line over here. So, this is what? The prime meridian. It divides the earth into two equal halves, like the equator divides the earth into two equal halves, northern hemisphere and southern hemisphere. The same way, the prime meridian divides the earth into two equal halves or hemispheres, the eastern hemisphere and the western hemisphere. Got it? Good. So, let us learn about longitudes. The longitude of a place is the angular distance of that place east or west of the prime meridian. Like latitude, what was latitude? Latitude means it is the angular distance of that place north or south of the equator, right. So, here it is the angular distance of a place east or west of the prime meridian. Okay. So, it is also measured in degrees. Okay, it is also measured in degrees. All longitude to the east of the prime meridian are denoted by the letter E. So, whatever is coming in the east side will be E. So while the longitudes to the west of the prime meridian, are denoted by the letter W, eastern part, E, western part, W. Dear kids, there are 360 meridians in all, 180 to the east and 180 to the west. So total how many? 360 meridians. Good. So the meridians are about 111 kilometers apart from each other. Okay, 111 kilometers apart from each other at the equator, and they meet at 2 poles. Here also they meet. You can see they meet at North Pole and also South Pole. Clear? So now, how can we locate the places on Earth? Next question. On a globe or a map, you will see that the parallels and the meridians crisscross each other. Okay, it crisscross each other and form a network or grid. So we can locate the places with the help of these grids. The point of intersection of parallel and meridians gives the exact location of a place. Good. So next we will discuss about longitude and time. Very important. Listen, it's very simple. Time can be commonly measured by the apparent movement of the sun in the sky. Okay, from east to west. So when the sun is at the highest point in the sky, it is noon. Very simple. So when the sun is at the highest point in the sky, it is noon. So as the earth rotates, each place has its morning, noon and evening. Okay. And do you know what do you mean by local time? Yes. Local time means all places located on the same meridian see the sun at the same position in the sky. Okay. So what all places are located on this meridian, they all can see the sun in the same place in the sky. So this is the local time of that meridian. Clear? Thus all places located on the same meridian have the same local time. Oh, suppose this is Greenwich. So all the places located on this meridian have same local time. So dear kids, one important thing, the word meridian is derived from the Latin word. Do you know what is that? Yes, it is meridianus, meaning midday. Meridianus means midday. Thus, meridian signifies the sun's position at noon. And if I ask you, what do you mean by this AM and PM? 11 o'clock AM and 6 o'clock PM. Can you expand the term AM and PM? See, AM stands for anti-meridian. Clear? AM stands for anti-meridian. That means before noon. So what is PM? It's not Prime Minister. What is that then? PM means post-meridian or afternoon. Good. AM for anti-meridian, PM for post-meridian. See, the earth rotates from west to east. Earth rotates from west to east. This is obvious from the fact that the sun rises in the east and sets in the west. Right. See, when the sun rises at a particular place, any place of its east has already seen sunrise and it is morning there. However, at the places to its west is still dark. That means it is night there. Got it? Good. And now we are moving further, that is calculating time. So be careful this time, my dear kids. And it's very simple. And now we are going to learn how to calculate the differences of times. Okay. Remember and listen me carefully. Places located on different meridians have different local times. We have already discussed about it. So the difference between two places can be easily calculated. See, the earth takes 24 hours to complete one rotation. We know it. So, earth takes 24 hours. That is, it has to cover 360 degrees of longitude. How many longitudes are there total? 360. So, full one rotation means 360 degrees of longitude. So, to cover 1 degree of longitude, it will take 4 minutes. Remember, very important, 1 degree of longitude means 4 minutes. Okay, this is the basic. Then, places in the east are ahead from places in the west. Dear kids, places in the east are ahead, we have to add, okay, and while west we have to subtract. So, henceforth, each degree of longitude towards east, 4 minutes have to be added, and while 4 minutes to be subtracted for each degree of longitude towards the west. So, here I have an example. How can we calculate the time? Here the question. Suppose it is 12 noon at Greenwich, that is 0 degree. What will be the time at 15 degree east and 15 degree west longitudes? So, here you can see the time difference is 15 into 4, that is equal to 60 minutes. How it came? So, here the 15 is already there, and as I said, 1 degree of longitude is 4 minutes, right? So, 1 degree of longitude is 4 minutes. So, here how many degrees are there? 15 degrees are there, no? Right. So, I am multiplying it, 15 into 4, that is equal to 60 minutes. 60 minutes or 1 hour. 60 minutes is equal to 1 hour, no? Good. So, we are calculating what is the time at 15 degree east. Here, thus, at 15 degree east, that is 12 noon at Greenwich, we have to add or subtract. While it is in east, we have to add. What we have to add? What is the calculation here? 1 hour. So, at 12 plus 1, that is 13 hours or 1 p.m. We are adding it. So, this is what the time in 15 degree east. And what will happen to 15 degree west? Here see, 15 degree west, that means 12 minus 1, this is the calculation we got. So, minus 1, so 11 am. So, shall we do one more example? So, it will be easy for you. So, I am just changing this question. Suppose it is 12, instead of 12, I am going to give you 5 p.m. So, 5 p.m. I am making it to 5 p.m. Okay. So, suppose it is 5 p.m. at Greenwich. What will be the time at what we can make into 10 degree east, and here can go for 20 degree west. How you will do? So, here we have to do, instead of the time differences is for east, we are going to do for east first. Okay. So, the time difference is, what is east? 10 degree. So, 10 degree, 10 into 4, 40, very good, 40, okay. And here 15, sorry, it is 10 degree, 10 degree east is equal to, what is the time given? 5, no? So, 5 plus 40 minutes. So, we have to add, no? So, the answer is 5:40 am or pm? PM. Good. So come back to the next, that is west. What happened to the west? What is the degree given? It is given 20. Okay. 20 into our common 1 degree means 4. 4. That is equal to 80 minutes. Okay. 80 minutes or how many hours? 1 hour 20 minutes. Okay. 1.2 hours we can write. So it is west, right? It is west. So what we have to do? We have to subtract 5 minus 1.20 p.m. How much it will come? See, 5 minus 5 o'clock minus 1.2. We will do once. 5 minus 1, 4. 4 o'clock you have to minus 20. That means 3:40 AM or PM? It is PM. Got it? This is the way we can do. So for east you have to add, west you have to subtract. Got it? So for one longitude you have to add or you have to multiply 4 minutes. So that's why 10 degree given. So you have to multiply by 4, 40 km. For 20, 20 into 4, 80 km. Got it? It's very simple. Practice more. And now we will move to the standard time. What do you mean by standard time? See, every country has a few meridians passing through it. Okay. So India, for example, has 30 meridians passing through it. In India, 30 meridians passing through it. So if each meridian were to follow its own local time, there would be a lot of confusion within the country, right? Regarding train and the flight timing and business schedule, etc. Okay. So to avoid this problem, the local time of the meridian which passes through the center of the country is taken as the time for the whole country. Okay, so which is passing through the center of the country. So this meridian is called the standard meridian. This is called the standard meridian and it is the local time. The local time is called the standard time of that country. Okay. So the local time of the prime meridian is called, very important, the local time of the prime meridian is called the Greenwich Mean Time, GMT. So what do you mean by GMT? Greenwich Mean Time. So the standard meridian of India is, remember the standard meridian of India is 82.30 degree east. Okay. So which passes through the city of Allahabad. It passes through the city of Allahabad and its local time is known as Indian Standard Time, IST, Indian Standard Time. So what do you mean by Greenwich Mean Time? So the local time of prime meridian and ours is known as Indian Standard Time. So IST. So and it is followed all over the country. Indian Standard Time is followed all over our country. So the difference between the IST and GMT is 5.3 hours or 5.5 hours. Okay. So the difference between the Greenwich time and Indian Standard Time is 5 hours 30 minutes. As our country is at the east of Greenwich, our standard time is 5 hours 30 minutes ahead of GMT. So if we are in the west, we are behind. So we are eastwards, so we are ahead of GMT. And our next topic, one more, that is time zones. Time zones. See, the earth has been divided into several time zones for our convenience. Okay. So since it takes 24 hours to complete one rotation, it takes 24 hours to complete one rotation, there are 24 time zones on 1 hour each. Okay. 24 time zones. Each time zones covers, remember, each time zones covers 15 degree of longitude. How many? 15 degree of longitude. So, do you know, kids, some countries have several time zones passing through. See, countries like USA, Canada and Russia have vast east-west extent. So, like Russia, USA and Canada have vast east-west extent and have great time differences in the eastern and western part. So, they cannot follow the same. So, hence such countries have been divided into several time zones, each with its own standard time. Okay. For example, USA has 5 time zones and Russia has, Russia has 11 time zones. Okay. So, our last topic, that is international dateline. Have you ever heard about international dateline? Yes. Let's see. So, we know that the time is added by 4 minutes for every longitude in the eastward and subtracted while going westward. But the differences at 180 degree east longitude is same as 180 degree west longitude. Okay. The difference at 180 degree east longitude is same as 180 degree west longitude. Good. So, to solve this problem, imaginary line was created. Do you know what was that imaginary line? Yes, that is known as the international dateline. So, it is quite interesting. See, listen, the 180 degree longitude passes through many islands in the Pacific Ocean. Okay, 180 degree passes through many islands in the Pacific Ocean. Thus, the international dateline is not straight but a zigzagging line keeping the island groups on either side of it. Okay. So, remember one thing, if you cross this line from west to east, we adjust our watches by adding a day. Got it? So, if you are moving from west to east, we have to add one more day in our watch, while we subtract a day when we cross this line from east to west. Amazing, alright? Good. So, dear kids, in your textbook, page number 21, you can see two solutions, two problems. So, the first one is method of finding time when longitude is given. So, let us see how can we solve this problem. So, the example is here. What is the time at Prayagraj 82.5 degree east when it is noon at Greenwich? So, the question is, what is the time at Prayagraj 82.5 degree east when it is noon at Greenwich? So, look at the solution. Difference of longitude between Prayagraj and Greenwich. See, we can see what is the degree of Greenwich, 0 degree, we know it. Okay. So, Prayagraj is 82.5. So, 82.5 minus 0 is equal to 82.5 degree. Okay. So, for 1 degree of longitude, there is a time difference of 4 minutes that we have already learned. So, therefore, 82.5 degree longitude, there is a time difference of 4 into 82.5. Okay. So, we have to multiply 82.5 into 4. So, the answer is 5 hours 30 minutes. So, now come here. Now, as Prayagraj is situated east or west? Look here, it is east. So, now Prayagraj is situated east of Greenwich. 5 hours 30 minutes should be added to the Greenwich time. Okay. So the time at Prayagraj is what? 5.3 hours, and Greenwich time, noon means 12 o'clock p.m. So 12 hours plus 5 hours 30 minutes we have to add. So 17 hours, answer is 17 hours 30 minutes or 5:30 p.m. 12 o'clock plus 5:30 is equal to 5:30 p.m. Got it? So now you can see the next method of finding the longitude when time is given. Method of finding the longitude when time is given. Look at the example. Calculate the longitude of a place whose local time is 12 noon while GMT is 6 p.m. Here we have to find the longitude. Okay. So here the solution. Difference in time between Greenwich and the given place. So Greenwich time is what? GMT 6 p.m. and the local time is 12. So you have to minus 6 p.m. minus 12 p.m. or 12 minus 6 or 18 hours, that means 12 hours. So 18 hours minus 12 hours is 6 hours. The difference is 6 hours or 360 minutes. How? 6 into 60. How much? 6 6 are 36. So 360. Fine. So there is a time difference of 4 minutes of one longitude. This is the common formula. 4 minutes for 1 degree longitude. Let's see. Therefore, a time difference of 1 minute will be 1 by 4 degree longitude, or what you can do, 360 divided by 4. You will be getting 9 4s are 36. So 0 0 0 you will be, so 90, you will be getting 90. So that means 90 degree. We are just dividing 360 into 4. Now see whether it is east or west. As the local time of the given place is behind that of Greenwich, behind, if it is ahead we are adding, addition for east, subtraction for west. So since it is behind, obviously it will be west. Therefore, the longitude of a place would be 90 degree west, since it is behind the Greenwich time. Got it? So please do more examples like this. You only can give variations in the time here, and try by yourself to solve both these methods. Got it? So dear kids, we are going to have a conclusion for our chapter in the form of a mind map. So here you can see in this chapter latitudes and longitudes. First we discussed about globe, and then further we move to latitudes and longitudes. So latitudes are the imaginary horizontal lines, right? And in that different parallels of latitudes. What are the parallels of latitudes? Tropic of Cancer, Tropic of Capricorn, then Arctic Circle, Antarctic Circle, and 0 degree equator. And we also learned about heat zones, 3 heat zones: torrid, temperate, and frigid zones. And about the longitudes, these are the vertical lines. We learned about the local time and calculating time, then standard time, that is GMT, Greenwich Meridian time, mean time, and IST, that is Indian Standard Time. And also we discussed about the international date line. So I hope you all have enjoyed the video. So please go through the chapter, read the chapter thoroughly, and try to solve the question and answers in the exercises. So all the best. We'll meet you in the next video. Till then, bye bye.